rain. Ooh, play. You know me again. Happiness and joy. Hello guys, welcome back to my live streaming. Okay, our topic for today is chemical bonding. Yesterday our topic is all about Lewis dot structure and there's Lewis diagram, right? So partly related here in number 4. So we have the chemical bond, 4 types actually of chemical bonding. Okay. So if you were going to take BS Chemistry, Bachelor of Science major in Chemistry, and if you take also Bachelor of Science major in Chemical Engineering, if you take also Education, major in Science and Teaching Chemistry, okay, so you need to understand these basic requirements. This one, okay, all about chemical bonding. So now I need to put 4 types, right? 4 types, right? Am I correct? Okay, we have the metallic bonding, the ionic bonding, and then we have the hydrogen bonding. Okay, and we have the covalent bonding, which has 2 types, right? Polar and non-polar. Okay, so you get the point. Things like that. So number 1 is very obvious. Okay, there's a metallic like that. Okay, and number 3 obvious also there's hydrogen. But before going further, I will be able to drink coffee muna, ha? To activate my neurons. Okay. Makaloka. Okay, Char. Oh, I love it. Let's check my way to Charlie. Hello guys, I'm coming back. Okay, so we need to understand here that this is really under physical chemistry, because physical chemistry is under chemistry, right? You get the point. So this is deals with the study of the attractive forces. Okay, what we mean here, the intermolecular forces or the attractive forces that binds the atoms together, okay, to produce compound or molecules, right? Things like that, compounds or molecules, because molecules are in the compound. Say if you have water, that's composed of 1 molecule of water. So in that molecule, there's uh, a lot of atoms banded together or binded together, right? Things like that. Okay? So the band formation is very important here. Band formation. Okay? Things like that. So I need to drink coffee muna guys. Nakakaloka rin. Okay? Sarap. Okay? Okay? Hello guys. Hello po. Okay. I will be seen in the screen or not? I think I will not be seen, right? Wait. Okay, so this is very, very easy to understand. Okay, look at point. Okay. But if we try to deal with, the discussion with intermolecular forces, that would be more, complicated to understand. You get the point? So there's ambiguity. Meaning to say, it's really ambiguous how to really determine the important, comprehension for the particular topic. Okay? So how to understand really, because too much, the atoms, the molecules, the forces involved in it, ganon. Okay? Oh, I love it! Nakakaloka. My breakfast is apple and brown bread only. Okay. Okay, guys. Okay. So, shararat. Shararat kayo guys, no? Okay. Yes. Hello guys. So I need to have my simultaneous live streaming for today. Happy Saturday to each and every one of us. Okay. Saturday. Oh, okay. So I need to connect the, you know. Oh, so what's happening here? Okay. Now, what? Okay. So like this. Okay. Yes. Yes, I love it. So you can see me now in my FB, right? So this topic really is very interesting because of the word bonding. So we love family bonding, friends bonding, okay, neighbors bonding, bonding, okay, public officials bonding, okay, senior citizens banding, the youth banding. So many type of bandings, right? Jowa to jowa banding. You get the point? Things like that. Okay, I love it. Jowa to jowa banding. Oh, I created my own, right? Okay. It's gonna be like that. So again, chemical banding is due to attractive forces, specifically intermolecular forces that binds the atoms together to produce a molecule or a compound. Okay, that's the definition of our chemical bonding. Okay. This is chemical bonding, action verb is bonding, and it will produce chemical bond. Things like that, okay? So metallic bonding first, we need to discuss a little bit. But I need to sip coffee. I cannot swing because it's too hot. And I cannot also chug either. Chug. Okay. You know the three modes of drinking? The sip, the swing, the chug. Wow, nakakaloka. Okay. Oh, I may also discuss your English language. My minds are too much, filled with English language and, a little, not a little, but some also, science, and then there's also occupational safety and health. Stuck up. So later, I think next week, we will be discussing about, safety and health, occupational safety and health. Okay? It's gonna be like that, I'm not sure of that, okay? And then there's no problem with mathematics because we can couple that somewhere along the way when our topic is science. Right? Oh, diba? Oh my gosh. I love it. Okay. Coffee everyone. Coffee to activate our brain cells because this contains caffeine and then it releases growth hormone, stress hormone. Nakakaloka yung stress hormones. Diba? Nakakaloka. Okay. Okay, magsugod ng taoy. Char! Okay, let's get started! Welcome to my science, safety, health, and music vlog. This is your content creator, Junjun Inglesero. I'm coming back, okay? So where's my, okay. Here. Okay, then after the discussion, we need to erase because there's not enough space in my whiteboard, right? Okay. So how can I write so many stuffs here or whatever? Okay, already occupied, alright. So metallic bonding first, so what you understand. So take note with the word metallic. Okay, so it's very obvious that it's a bonding that involves metals. Okay, driven by metals. Okay, plus polyatomic and ion. What do you mean by polyatomic and ion? Actually, there's a lot. Okay, for example, nitrate, like that. So the charge will be negative, or let's say an ion. Get the point? Negatively charged. Okay, so example. We don't have to give you so many examples, right? Because it's very obvious, right? The space is very limited. Okay, silver nitrate. Okay, things like that. Okay, so you add the silver plus nitrate, it will become silver nitrate. Okay, so many things also, so many examples. Okay, now be careful in doing this because if you add oxides, this is not metallic bonding. Okay, you get the point? So be careful also. It's only polyatomic and ion, but take care with those norm. You know what's the norm in chemistry? Naturally occurring, okay, metals. Naturally occurring radioactive metals or metals. It could be the norm and the norm. Okay, so somebody siya. Okay, let's see. Gold. Okay, the auric. Okay, this is gonna be AU, the silver, AG, right? The mercury, HG, the copper, right? The cobalt, the lead, okay, the zinc, the tin, right? Tin. So tin is gonna be SN, right? Then SB is antimony. Correct me if I'm wrong, because when I was in high school, I always interchanged the antimony and the tin. Really? Until now I'm confused. Okay, so SB is gonna be taken from strontium, right? So I think SN is the tin and SB is the antimony, right? Correct me if I'm wrong, right? Okay. Or it's the reverse. You can help me also. That's 30 years ago in my chemistry. Okay, so if this, let's review SB, this strontium. There's no connection of the word antimony and strontium. Then SN, tin. So it looks like, okay, because there's letter N. Okay, so things like that. Zinc, lead, cobalt, okay, gold, okay, and then we have the silver, mercury, and copper. So take note with this, okay, naturally occurring metals, because sometimes other metals will not be belonging to the metallic bonding, okay, especially if you add with oxides. For example, let's say mercurous oxide, mercuric oxide, iron oxide, things like that, right? So iron oxide is not under metallic bonding, but it's also metal. But because iron is not under naturally occurring metals, so sometimes you need to dig deeper, okay, when you read the content in the particular topics because there are exemptions. You get the point? Things like that. You get the point? But the obvious here is the metals. You need to attach that with polyatoms. It could be silver nitrate, okay, okay, auric nitrate. You cannot say gold nitrate, ha? That's wrong grammar in chemistry. Okay, you will say auric nitrate, mercurous or mercuric nitrate, things like that, and coprous or copric nitrate, things like that. You will never say also iron nitrate, ha? That's wrong. If you forced to do that, then put the number iron 2, iron 3 nitrate. Okay? Or copper 2, copper 3 nitrate. But if you only say copper nitrate, it's not possible because there's two charge, the positive 2 and the positive 3. So it's a bit confusing. Okay, if you use positive 2, it is coprous. If you use positive 3, it is copric. Then you will say cuprous oxide, copric oxide, but you never say copper oxide because there's two variations, two versions like that. Okay, so in order you can use the word copper, then put the Roman numeral either 2 or 3 oxide. Copper 2 oxide, copper 3 oxide. Okay, it will be really wrong. Okay, you get the point. So be careful also. You get the point. Iron oxide. Oh, so what you mean by iron oxide? There's ferrous, this ferric. There's F2O3 and there's also F3O4. You get the point? Okay, because there's also magnetite. You get the point? We have hematite, magnetite, ganon. You get the point? Things like that. Okay. So, masimeta po. Okay. So, I magnetite is Fe3O4. Okay, things like that. Okay, and then ferrite, Ferrite, it's gonna be Fe2O3. Things like that. So there's equivalent kasi in the chemistry, the name. Sometimes it will be coming out in the examination and you need to identify. For example, which of the following is a limonite? And then it will give only the formula A, B, C, D, E. Question number 2. Which of the following is a lanolin? A, B, C, D, E. The chemical formula will be displayed with the choices. Which of the following is a linoleic acid? Things like that. A, B, C, D, like that. Because they did it intentionally because the students not caring for that. The students most of the times, they cared how to master the chemical formula. They are not trained to extract the names. Okay, because it needs a lot of memorization, right? For example, what is a sour gas? A, carbon dioxide, B, carbon monoxide, C, nitrous oxide, D, none of the above. This will be like, in the board examination, it's always like this. In the principles and chemicals, day 2 or day 3, things like that. Okay, so you have to identify. Now, if you're not a wide reader, sometimes you forgot, and then it's also not discussed in your review. Okay, things like that. You get the point? Manashimeta po. Okay, so metallic bonding it looks like very easy, right? Okay, and there's also the opposite of that charge. Say negative and positive also. Things like that. In metallic bonding. Okay, it's very easy for the metallic bonding, right? Okay, so alloying. Okay, alloying is not a metallic bonding, because it's all positive. Okay? For example, when you blend zinc to copper, when you blend iron to, let's say, arsenic or antimony like that, that's a process of alloying in metallurgy study, right? Okay, so that's not what we mean here, Get the point? Things like that. And then you say diamond also. You know diamond is the precious stone. So diamond is not a compound. Let's make it clear. A diamond is not a compound. It's not also an alloy. Okay, that is only an allotrope. Or allotrope, the other form of carbon. Okay, because carbon exists in graphite, diamond, like that. Okay, you get the point? Ganon. Okay. Just like the calcium carbonate, limestone, and then sometimes it will also exist as a calcite, things like that. You get the point? So you only remember the name and the equivalent formula. You get the point? So usually like that, huh? Mm. Okay. Now, going to ionic bonding. Okay. So by the way, allotrope, okay, is the different form of the same element. Only the form changes and the appearance changes, but still the same. Okay, that's allotrope. Isotope is another thing. Okay, elements have the same atomic number, but different mass number. Okay, that's isotopes. Carbon 12, like that, blah, 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 so on. So, okay. So, you know what I mean. Okay, number 2, ionic bonding. Okay, what is ionic bonding? So, investigate the terminology first based on our understanding. Ionic, so it has to do something with ions. Ions-driven bonding. See, you can make your own definition. Ions-driven bonding, or it is a bonding driven by ions interaction. So English matters, okay? How you make the definition. Okay, things like that. So it's a type of one of the type of bonding or chemical bonding that involve ions. Things like it's also okay, right? So ionic bonding, things like that. Okay. So ionic bonding is gonna be the combination of metallic and non-metallic. Okay, metallic and non-metallic. Okay, so driven by opposite charge, opposite formal charge, positive and okay, negative, like that. For example, sodium positive and chloride negative. So sodium chloride. Okay, this is ionic bonding. Things like that. And there's a lot. Okay? Things like that. Get the point? Okay. Now if you say iron chloride, what's this? It's still ionic bonding, right? Okay, get the point. As long as metallic plus non-metallic. Okay. Okay? Now we go to hydrogen bonding. Okay, what do you mean by hydrogen bonding? Okay. So, when we mean by hydrogen bonding, it's exclusively in polar. Okay? Polar molecule involved. Polarity. High polarity. Okay, high polarity. Or the product will be a polar molecule. Okay, like that. And there's always attachment of hydrogen in the bonding. If there's no hydrogen, then that is not a hydrogen bonding because very obvious. See? Hydrogen bonding. Okay, things like that. You get the point? Ganon. Okay, things like that. Okay. Now, number 3. Okay. Number 3, mga palangga. Okay. We have the covalent bonding. So, I love the covalent bonding. Okay. You get the point? Covalent bonding are non-metal plus non-metal. Non-metal plus non-metal. Okay, like that. For example, hydrogen, oxygen, okay, chlorine, carbon, sulfur, oxygen, okay. Dito pa so carbon, sulfur, phosphorus, nitrogen, okay. These are all non-metals, huh? Sometimes it can be interpreted as metals, but it's not metals. Okay, because you found a powder in solid form. You get the point? So there's a lot of non-metals that there's an appearance of somewhat solid, but it's not metal. Okay, like carbon, sulfur, phosphorus, things like that. You get the point? Okay, so you get the point. So non-metal and metal. Okay, so we have the two types, the polar and non-polar covalent bond. Okay, polar meaning non-equal sharing of electron, an equal sharing of electrons, an equal sharing of electrons. Okay, and non-polar will be equal sharing of electrons. Okay, example of our polar, again water, like that. Okay, H2S, like that. Okay, and so many things. Okay, got the point. Okay, now non-polar, exclusive for, okay, hydrocarbons. All hydrocarbons starting from methane going to duodenane. Okay, methane, ethane, propane, butane, heptane, okay, heptane, pentane, octane, nonane, okay, denane, and dodecane. Okay, so arrange properly the carbon of atoms from 1, 2, 3, 4, 5 until 12 atoms. 12 atoms will be the duodenane. Okay, get the point? Okay, so let's say duodenane, 12 atoms of carbon. Okay, since we are E, we need to use the formula of CnH2n, okay, plus 2. So C12, H2 times 12 plus 2. C12, 12 times 2, 24 plus 2, 26. So the formula of duodenane, okay, is 12 atoms of carbon and 26 atoms of hydrogen. By using this, use only this formula if you forgot the chemical formula of, say, butane, propane, okay? You get the point, but these are common, so it's understood to be memorized already. The propane, the butane, like that. Okay, the methane, but it will increase, right? Heptane, hexane, like that. Okay, now in hydrocarbon, you need to memorize the most commonly used hydrocarbon, which are propane, butane, methane, and gasoline. Okay, so gasoline is an example of octane. So it has 8 atoms of carbon and 18 atoms of hydrogen. Okay, things like that. So this is the most popular in the hydrocarbon, the gasoline. Okay, and the propane and the butane, liquefied petroleum gas, LPG. Okay, things like that. So in chemical engineering and basic chemistry, you need to memorize all for this from 1 to 12. Okay, but your instructors, professors will not say that. Okay, it's your own resourcefulness and initiative. Okay, things like that. Okay. Then hydrogen bonding, let's go back to the hydrogen bonding. Okay. So I did not have the example. We have, let's say, a bond between oxygen and hydrogen. Okay, a bond between, let's say, oxygen and hydrogen. A bond between, let's say, you know, boron and hydrogen. Okay? Boron, yes. Okay? as long as there is an edge. Any questions so far for this basic chemical bonding? Okay, again, we need to remember to recap. The chemical bonding has attractive force in which intermolecular forces, okay, to let the atoms combine to produce a compound or a molecule. There are four types: metallic bonding, ionic bonding, hydrogen bonding, and covalent bonding. Covalent bonding composed of polar and non-polar. Okay, metallic bonding driven by the involvement of metals. Ionic bonding driven by the nonmetals and metals. Okay, hydrogen bonding driven by the reaction of hydrogen atoms. Covalent bonding, okay, driven by polarity and polarity, which is the sharing of electrons. Okay, sharing of electrons. By the way, also, the transfer of electrons is ionic bonding. Transfer of electrons. Okay, it looks like the same, right? But you need to be careful if the question will say, which of the following involves transfer of electrons? And you may confuse between covalent and ionic because once you share, you also transfer, right? Agree or not? Once you share, an example of sharing is to transfer. Okay, to move in English language. So it looks like related when you say, when you transfer, of course you share. For example, if I transfer my money to my mother after my salary, we need to say I share my salary to my mother. Actually, they are just the same if you try to be strict. But in chemistry, there's a difference between the two because what we mean in transfer here is you will not transfer back, only transfer the other one. It doesn't mean that the recipient will also transfer back to the one who gave. This is what it means. You get the point? If hydrogen will give to fluorine, only hydrogen will give to fluorine. The fluorine will not give back to hydrogen. Things like that's what it means here. You get the point? Okay, let's say sodium and chloride. Since chlorine is the electronegative. Of course, the atoms of sodium will be directed towards the chlorine. Okay? So the chlorine stable. Okay? Because he is or she is electronegative. So that's what it means by transfer of electrons. But in short, both are sharing. You get the point? So there's a very small difference. Be careful also. Okay? Things like that. Okay? You need to be clear in your memorization because both involves electrons, the K word of ionic bonding and covalent bonding. So it's a matter now of your action verbs, whether you transfer or whether you share. Okay, if you share your electrons, that is covalent. If you transfer your electrons, that is ionic. Okay, then through charges, positive and negative, or anions and cations like that. Okay, got the point? Bye bye, God bless everybody. I hope you like this short and quick vlog of mine. You can comment down below in the comment section. And then you can also subscribe my YT channels if you want. I have two channels, okay? The exclusive singing and science, health, and safety music in YT. Okay, and I have also two accounts in FB. Then if you will ask for friends request, then I will be able to accept you. Just do it politely, okay, and professionally. Okay, thank you so much. Remember that Jesus loves us. See you later. Okay. Hi. Third topic. Wait. So nakakaloka.